Hello and welcome back. Further maths today. We got this particular question. I think it's on the core of further maths. We got the function f of x is equal to the arctan of sine x over the cos of x minus 1, defined between 0 and 2 pi, not inclusive on either end. And the question says, prove that f of x is a straight line. Okay, I was going through this question with one of my students the other day. It's actually a 4.5 star as it is in there. If another clue was given the question or phrased slightly differently, it will drop it down to 4 star. Because most people, when we perhaps we look at this, we think, okay, let's manipulate that and hopefully we'll come up with a straight line, which is going to be kind of difficult to do it this way. But there is another way, and the key word there is differentiation. So if the word was use differentiation to prove that f of x is a straight line, immediately the question becomes a lot simpler. And we're going to try it this way. Okay, so let's start by differentiation. I'm going to put here the standard differential for the arctan. So we have it in front of us. d by dx of the arctan of x is, of course, 1 over 1 plus x squared. We should all know this. So we're going to differentiate and get an f dash of x for this particular expression. This is a lot more messy. So let's have a look. The arctan differentiates to 1 over 1 plus x squared of its argument. So we need to do this bit first. So 1 plus, that's the argument now of the arctan in there. So that's all of this. So I'm going to write it straight away as sine squared of x. I'm not going to expand the denominator. I'm going to leave it as it is. Cos x minus 1 all squared. So that is just this bit here, but that doesn't stop there because, of course, now this argument has a differential itself. So it's times d by dx, of course, of the sine of x over the cos of x minus 1. If you can see this, you don't really need to write that. I just wrote there for detail. So we need to multiply this quantity by the differential of that, which is, of course, a product to differentiate. It's not a product, sorry, a quotient to differentiate. Okay, I'm going to rub off this line now and actually go straight into that and do the quotient rule on this particular bit, so we don't have to keep writing the same line over and over again. So, big fraction line. We start in the product rule for, not product, keep saying product rule, the quotient rule for this particular one. So denominator squared, cos of x minus 1 all squared. That's rather nice because, of course, I think we'll cancel some of these things when we multiply it out. So we start with this on the top left, cos x minus 1 undifferentiated, times the differential of the numerator. Sine differentiates to positive cos. The quotient rule has a minus, and then we have to leave the numerator alone, sine of x times the differential of the denominator, which is the cos x minus 1. The minus 1, of course, does not produce anything, but the cos of x goes to minus sine of x on differentiation. So a little bit of a tidy here. Now, do we expand this? Of course not. We're not going to expand it. We're going to leave it as it is for the time being because it's rather nice. 1 plus sine squared of x over the cos of x minus 1 all squared. And then the big tidy is really on this term here. Again, the denominator, we're going to leave it as it is. I could have actually multiplied it on this line here, but I'm going to do it on the next line. It's probably better. Let's clear this top first of all. This pen is drying up, so let's change pens. So when we multiply that, we're going to get a cos squared of x minus a cos of x plus a sine squared of x. Okay, is that nice? Of course it is, because if I put it on the same now fraction, I'm going to do that on this side of the board, hopefully still visible. On the numerator, it's going to be, of course, that times that. And, of course, this is a 1. Cos squared plus sine squared of x is 1. So I'm going to write 1 minus the cos of x. On the denominator, this is what I'm doing. I need to multiply this denominator with this, so it's 1 times this bracket here. That's the cos of x minus 1 all squared. And of course, I need to multiply this by this, but then of course, this denominator will cancel with this denominator from this fraction. So it's always going to leave me is the sine squared of x plus the sine squared of x. Okay, let's continue with this particular line. On the numerator is 1 minus cos x. Now we reach the end of the line with this. We have to expand it. I can see cos squared x plus sine squared x, which will simplify nicely at some point. So cos x minus 2 times the cos of x plus a 1, expanding the bracket, plus of course the sine squared of x, which was already there. That and that is of course a 1 plus another 1 there. Altogether we have 2 minus 2 lots of the cos of x. And on the numerator, 1 minus the cos of x. And this will simplify now very nicely. Factorize the 2. We get exactly the same term on the denominator. So the answer is half. Okay, how does that help us now using differentiation, of course, to prove that it's a straight line? A straight line, of course, we should know that it has a constant gradient. And the gradient function here turned out to be a half and independent of x. So this is a straight line. We can actually find whether this line is going through the origin or not by just substituting a suitable value just to find this full equation. But the question does not actually ask us for this line. It says prove that f of x is a straight line. We need to put a finishing comment there. As the gradient of the function is constant and it's a half, this represents a straight line and there's nothing else to say. I hope you followed all of this. I hope you enjoyed it. Who's laughing now?